Sometimes the chain rule occurs in conjunction with the product and quotient rule. This really does require a good bit of practice, so you need to be patient. Radicals make it worse. There's also some weird factoring involved when you get common denominators that can throw things off as well. So we're just going to kind of start here, and we're going to look at f of x equals x squared times the square root of 1 minus x squared. Is there any way to distribute that? Like, even if I rewrote that as 1 minus x squared to the 1/2 power, could I distribute the x squared? I couldn't, because I can't distribute into something that has an exponent on the outside. So because of that, you have no option. You have to do the product rule for this one. So we're going to do the product rule, and we're going to come out to the side, and we are going to identify what our first function is, and we're just going to let it be what?
X squared.
Okay? And what are we going to let our second function be? The square root of
Square root of
1 minus x squared. And it will help if you also write that in exponential form, because that's how you take derivatives, is from exponential form. So we'll also look at it as 1 minus x squared to the quantity 1/2 power. That's our second function. Then if we take the derivative of the first, that will give us 2x, and the derivative of the second is where the chain rule comes in. Because it's a binomial to a power, you have to apply the chain rule. So we say, to find the derivative, 1/2 down 1 on the power times the derivative of the inside. So technically, that is the derivative, but I want it in a format that's going to make it easy for me to work with algebraically. So I'm going to go ahead and I'm going to clean that up and make it, what is 1/2 times negative 2x?
Negative x.
Negative x. So I'm going to make it negative x, and I'm going to drop this guy into the denominator and put it back in radical form. So I have negative x all over the square root of 1 minus x squared. If you will go ahead and do that off to the side, it will make the actual problem a whole lot better. So go ahead and do this part off to the side. And now you're prepared to just fill into the formula for the product rule. Any questions about how I found the derivative of that second function? Okay. So let's see if we can fill this in. We know that f prime of x equals the first times the derivative of the second, which is x squared times this guy, which would really just be negative x cubed over the square root of 1 minus x squared. So that is first d second. Then I'm going to add to it second times the derivative of the first. So plus second d first, which is just 2x times the square root of this. And radical form is best when you're filling into the formula. So 2x times this. Technically, that's all of the calculus there is. I'm going to pause for a second and let you kind of catch up and see if you have any questions so far. Okay, so the only thing left to do is to get a common denominator. So we'll put this over 1. The nice thing is, it's not like the quotient rule, so we don't have complex fractions. All we have to do is get a common denominator. So in this case, we'll go ahead and say we're going to let the whole thing be the square root of 1 minus x squared. Then I just have to multiply the second fraction by that and see what I get. So the first fraction's okay. It already has my common denominator, so I'm just going to leave it as negative x cubed for its numerator. But the second fraction has to be multiplied on top and bottom by the square root of 1 minus x squared. And the nice thing about it is you should by now understand that those radicals have to disappear. So I have plus 2x multiplied by, what's the square root of this times another square root of that? So the radicals disappear.
So you have to distribute.
And now you have to just clean that up. And the way to tell if you must distribute or if you can stop is whether or not you still have parentheses and you have addition or subtraction outside of those parentheses. And we do. Because this plus sign is outside of the parentheses, we are going to be forced to go further. And the only way to do that is to distribute and see what we get. So we have negative x cubed plus 2x minus 2x cubed all over the square root of 1 minus x squared. Alright, if I clean that up, I get 2x minus what?
3x cubed.
2x minus 3x cubed all over the square root of 1 minus x squared. And those aren't like terms, so technically I'm pretty much finished, although I could factor an x out, right? So if you really want to go to factored form, and eventually the directions will state that, then we should go ahead and factor an x out and get 2 minus 3x squared all over the square root of 1 minus x squared. And if you can do that on your own, you should feel fairly accomplished for Cal 1 students. For this example, we have g of x equals x over the cube root of x squared plus 4. I think we'll all agree that this is going to require the use of the quotient rule. So the best thing to do is to come out to the side and go ahead and get everything lined up that you're going to need. So what's our top function? Just plain x. And our bottom function, that's not the low function. That's the high function, right? Have we been doing the low function first or the high function first? Oh, that's so weird. Okay. My brain hurts.
Doing low first.
Alright, let's do low first. Our low function is just the cube root of x squared plus 4. But it's going to help us if we also envision that as x squared plus 4 to the what? 1/3. Alright? Now our high function is just plain x. Okay? And our d low is going to be fun. It's going to be 1/3 x squared plus 4 to the negative 2/3 multiplied by what? 2x. Okay. So we have 1/3 x squared plus 4 to the negative 2/3 multiplied by 2x. So we need to go ahead and clean that up and get it into a workable format. If I multiply, let's just see what's on top. The only thing that needs to be on top is what? 2x. And on bottom, I already have a 3. And then this negative is going to drop this back into the denominator, and we're going to rewrite it in radical form as the cube root of x squared plus 4 quantity squared. Exactly. So that's our derivative of our low function. And now we're just missing the derivative of our high function, which is just what? So the derivative of the top is just 1. So we can be thankful for that one. Now that we have those 4 things already worked out, we can just plug into the formula that we have that states we can multiply low d high, which is just 1 times the cube root of x squared plus 4, minus high d low, which is just, oh my, x times that. So 2x squared over 3 cube roots of x squared plus 4 quantity squared. Nice. 2x squared all over 3 cube roots of x squared plus 4 quantity squared. All over what? Low. How do you square a cube root? You just square what's under it. Yeah, you just square what's under it. So we have the cube root squared, or cube root of x squared plus 4 quantity squared. So there we have it, you guys. That's all of the calculus. I'm going to pause for a second, and then we're going to go through and get rid of those inside fractions so that we don't have a complex fraction. Alright, so now we need to get rid of our complex fractions. So we're going to envision this as over 1. We're going to multiply all of the terms through by what's causing the problem. The only thing causing the problem is this guy. So I need to multiply everything by 3 cube roots of x squared plus 4 squared. So I'm going to do that to all 3 terms. 3 cube roots of x squared plus 4 squared. 3 cube roots of x squared plus 4 squared. And we have to do that on bottom as well. 3 cube roots of x squared plus 4 squared. So if we look at the top, we are expecting the radicals to disappear from the numerator, and they do. I'll have a 3, and then these two together will make a whole, right? Because that's 2 and that's 1, and we need 3 of them to make a whole, to undo the cube root. Okay, so really we just have 3 multiplied by x squared plus 4. Minus, over here, everything cancels in the denominator with this, so I really am just subtracting 2x squared. And the bottom, I have a 3, and I have 2 cube roots of x squared plus 4 squared, which really would bring it up to what power?
4.
To the 4th, yeah. You add your exponents when you multiply. So I'll keep the cube root, and I'll have x squared plus 4 to the 4th power. And you do not have to simplify improper radicals. You can just leave them just like that. So the bottom is done.
Oh, thank God.
The top just needs to be distributed and cleaned up. So the top will give us 3x squared plus 12 minus 2x squared, or x squared plus 12, all over 3 cube roots of x squared plus 4 to the 4th power. So it really isn't that bad. It just looks really ugly in those intermediate steps. For our final example of the day, we have y equals quantity 3x minus 1 divided by x squared plus 3 squared. So we have a quotient squared. So there are actually a couple of ways we could work this, but I'm going to show you what I think is the most logical that you would try to do as well. If I have a parentheses to a power, I just want to do the chain rule to it. Agree? And the chain rule states that anything to a power can be differentiated by taking the power times the coefficients, down 1 on the power, times the derivative of what?
The inside.
That's where things go bad, because the inside involves the quotient of 2 variable functions. So to find the derivative of the inside, I need to multiply all of that by the quotient rule of what's inside that parentheses. So I'm going to come off to the side. I'm going to talk low, high, D low, D high. To prepare myself to multiply by the derivative of that parentheses, because to take that derivative I need the quotient rule. Make sense, you guys? All right, one more time from the top. Power times coefficient gives us 2. Down 1 on the power gives us 3x minus 1 over x squared plus 3. And now we need to multiply all of that by the derivative of the inside. But to find this derivative, I have to apply the quotient rule.
Right.
So we're going to multiply by low D high, which is just 3 times x squared plus 3. Minus high D low. All over low, which is what? X squared plus 3 quantity squared. I wish I hadn't put that parentheses. Can I take this off? Because I really don't need it, do I? Look, can I take this off? Will it bother you? Do y'all see that? Okay. Alright. So let's take a look at that. Well, I guess it's okay to leave it there. I don't know. Doesn't matter. Okay, so here's what I have so far. I have 2. I have 3x minus 1 over x squared plus 3. And if you want, you can envision the 2 as over a 1. And I need to do a little distribution to clean up the numerator of this guy, but the denominator is fine. Now we just have to talk about cleaning up that numerator. So if it won't bother you, I'm just going to go up above it, and I'm going to distribute everything and see what my like terms are. This will give me 3x squared plus 9. If I distribute the minus 2x, I get minus 6x squared plus 2x. Let's pause for a second and make sure everybody's okay. So this gives us negative 3x squared plus 2x plus 9. All right. So what we have are 3 fractions multiplied together. So I'm just going to make them into one big fraction. And that gives us 2 times 3x minus 1 times negative 3x squared plus 2x plus 9 all over 1 times this times this. Do you guys see that these guys have the same base?
So that's just a cube.
That's
right?
just a quantity cubed. X squared plus 3 quantity cubed. And that we know we're done because we have no addition and subtraction remaining outside of parentheses. And we have it as one big fraction.